All right, so today we'll talk object-oriented programming in R. So let's do this. Okay. All right, so we'll talk object-oriented stuff. Basically, so you've got base types in R, which is kind of what we've been dealing with this whole time. Functions and vectors, matrices, lists, those are all base types. And then you can complicate those things by making them objects, classes of objects, okay? So when you ask R for the type of, it's going to return base type, right? You say type of, and you give it a vector, it's going to say integer, or it's going to say double, or something like that, right? So we've been dealing with an object type already, and a factor is an object in R, okay? So that's why when you say ask R for the type of a factor, what does it say? When you create a factor in R and you ask type of, it will return integer, right? The base type of a factor is integer. So, but if you ask class of a factor object, it's going to say factor, okay? So when those things are different, that kind of tells you that you've got an object, right? And so basically an object makes, you build them up with base types or whatever it might be, but you give it certain attributes, and then they behave a little bit different from the regular base type, okay? And with R, things are a little bit unusual in that we have three different object-oriented systems. We've got S3, that's the most common and probably, most commonly used object-oriented system in R. But then there's also S4, which is a little bit more formal, and then we'll also cover reference class type objects, okay? Today we'll just spend time talking about S3, S3 object-oriented programming, okay? I don't know if you guys have taken learned other programming languages and learned object-oriented systems there. Like in Python, you've got objects, and Java, you got objects. Those object-oriented systems are different than the way R handles objects, okay? So in R, we have, it's called generic function an object-oriented system, okay? So most other systems, you'll have an object, and that object will have certain methods, okay? The method belongs to the object. Whereas in S3's object-oriented system within R, the methods belong to the functions. So it's a little bit strange, okay? Or it's just a little bit different. Now, if this is your first time encountering any kind of object-oriented system, it might not feel that weird because you haven't seen other systems. Okay, and then we got S4, which is basically S3, but more formal. You have to define a lot more stuff. And then we have reference class, which is message passing object-oriented. And so this is kind of the system that resembles most other languages, like Python or Java, where where the methods belong to the object classes. Okay, why are we bothering with all of this? Okay. Oh yeah, sorry. Let me talk about base types. Okay. And base types are the ones that we've already covered. Those underlie everything, and we build our object-oriented stuff. We build classes of those out of the base types. So usually we combine lists with functions to kind of create our object-oriented system. Lists or vectors or whatever it might be. Okay, so we'll start with base types and all of this. A lot of the functions that you use in R output classes that are objects. So if you use LM to create a linear model, the thing that it outputs is an object of class LM, okay? And it has its own print method, it has its own summary method, and all sorts of stuff, okay? The object-oriented system in R, what that allows you to do is it allows you to just remember a few functions that will work for all sorts of different things, right? For example, R has a summary function. And if you use the function summary on a numeric vector, what does R output? It outputs, summary statistics, pretty much a 5-number summary plus the mean, right? So it outputs like the min, the max, the quartiles, the median, and the mean, things like that, right? But then if you create a linear model, right? You use LM to fit some kind of linear regression thing, and then you use summary on that, what does R output? It outputs kind of the details of that linear model, right? How does R do that, right? Is it the same function? You're just writing summary, and you put in different things, and R somehow knows to give you different results. R is not trying to give you a 5-number summary when you type in summary on a linear model, okay? That's what the object-oriented stuff allows you to do. Rather than having to remember something, some kind of function like summary.lm or whatever it might be, some kind of function specific for each type of thing, all you have to do is type in summary, right? And then when we use print on a list, what R outputs looks different from when we do print on a numeric vector or when we ask for print on a factor, right? When we ask print on a factor, it prints out the factor and it also prints out level information, all sorts of stuff. So that's what the object-oriented system allows us to do. Okay, so Hadley Wickham has written this package called Prior, okay? I would say we really only use this package for this lecture in terms of investigating the details of some kind of object-oriented stuff. In your day-to-day stuff, I've never really used Prior. But as far as illustrating what we're learning here, it's a useful package. All right, so let's talk base types. Okay, so it says underlying every R object is a C structure that describes how the object is stored in memory. Okay, so the R language is built on top of the C language, right? And we don't actually have to program anything in C, but C is much faster and stuff, and so a lot of these things run in C or even Fortran underneath the hood. Okay, and so the structure includes the contents of the object. And this is needed for memory management and all sorts of stuff like that, okay? And we've already covered those base data structures, and the most common ones being atomic vectors and lists. And base types also encompass functions, environments, and other things, such as names, calls, and promises. You use type of, and that will return the base type, okay? And it says, unfortunately, the names of base types are not used consistently throughout R, and the is function might be different, right? So we've got type of F, and when you put in a function, it will say closure, but then we don't ask, is it a closure? We ask, is it a function? Is.function, right? And then there's a function called sum, and that's known as a built-in. So this is like a primitive function where the code for, we can't get to see the actual code for the sum function. The sum function is written in C to kind of speed up the handling of stuff, okay? But then it's known to R as a primitive function, okay? So, that's unfortunate that it's inconsistent in the naming systems, okay? We've got mode and storage mode, and to see if an object is a pure base type, okay, you can run this command is.object, and it will return false if it's just a base type object. So those being the vectors, the lists, and the functions, and a few other things. Okay, So S3, this is what we'll talk about today. This is the first and simplest object-oriented system. It's the only object-oriented system used in all the base and stat packages, okay? And it's probably the most common one as far as R programming goes. It's very informal, and there's a certain minimalism in that it is a fully functioning object-oriented system without any kind of real frills, okay? We don't have a way to check if it's an S3. You have to say, is it an object? And is object needs to return false? I mean, needs to return true. But then you have to say, is it S4? And that needs to say no, okay? Because there's no function that says, is it S3? So, and the only way to check that is it an object? And that it's not S4, okay? We also have this command otype. Otype is a function that exists in the prior language only, and this will return S3 if you use the function otype after loading library prior. Okay, so for example, a data frame. I forgot. Yeah, a data frame is an S3 object type. Okay, because if we think about it, the data frame is actually a list, right? The data frame is a list. And if we ask the type of on a data frame, it will say it's a list. But it's a list that has that we display as a two-dimensional structure. And so it's the functions for data frame are built on top of the way on top of the list. So we can say what's the object type of a data frame, and it's going to say it's an S3. If we use library prior. However, if we subset the data frame to just column X, which will simplify to a vector, right? Using the subset notation, it simplifies to a vector. So asking object type on the vector, we'll say it's a base. Okay. When we ask for the object type for Y, Y is the character, it's character information going in, but the data.frame command or function automatically turns string data into factors, right? Strings as factors is default true, so df $y will be a factor, and that's object type S3. Here, let me come up to here. Okay, so we'll do this. So if I ask df $x, this is a vector. df $y, this is a factor, right? So if I say type of on this, what will the type of be? Integer, right? Okay. If we ask class, it will say factor, and if I use the function otype, this will say it's an S3 object type because factors are S3 objects. Okay. Was there a question?
Yeah.
Yes.
So why the factors will turn into when you ask for the type?
What's that?
So ask for the type of the factors A, B, C, D, Y will return an integer.
The type of for df $y, df $y. So this is a factor, and
so why is it like an integer?
So I think we did this in our homework, right? So when it's an integer, it just stores the underlying stuff as numbers, but then if we ask for the attributes of this thing, it keeps information about this called levels, and it matches the levels to the integers. So if I do factor hello bye, okay. So it's got hello bye. Let me just, okay, and so if I say type of dd, this is an integer, and if I say as.integer, what's as.integer going to look like? 221, right? It's going to be 221 because if I do attributes of DD, it's going to say here are the factors. The factors are bye and hello. So this just causes when we ask for the D to print out, whenever it sees the 2, it's going to replace it with hello. And whenever it sees the 1, it's going to replace it with the first level bye. It's just how R stores factors in the system.
So the shorter characters are automatically assigned a lower level?
It's alphabetical.
Alphabetical.
Yeah, so B comes before the H in the alphabet, so B gets assigned to a 1. That's the default setting for things. Okay, yeah, I'll just say a factor is an S3 object. Okay, we have in R we have generic functions as the way we handle our object-oriented programming. Okay, so if we ask for the function mean, okay, so you can always ask what is, so normally you would call mean on some vector, right? You'd say mean on 1 through 10 and it would say 5.5, right? But if you just type in the name of the object with no parentheses, right? The name of the function with no parentheses, then it pulls up the code that R executes when you do it. And you'll notice the code says use method, okay? Use method is an indicator that this is a generic function. So same with print. If I ask, how does the print function work? It's going to say use method print. This is an indicator that this is a generic function. So the generic function allows you to use the same function for different object types, right? So summary was another generic function that I mentioned. Use summary. So when we ask print on this object type, it does its own, it executes code specific for that object type, right? When we ask summary on a vector, it's going to run code to output a 5-number summary. If we ask summary on a linear model object, it's going to run the code specific for outputting the summary for a linear model object. Okay, and so to indicate that we can use the same function for different object types, when you look at the code for that function, you're going to see the word use method. This means this is a special function. So the use method basically says this is a generic function, and a generic function is one of those special functions where the same word, the same function, can be called to different object types, and it will run code specific for each of those different types of objects. So that's how we can run summary for different types of things, and it still works without having to call specific code for each one. Okay, so you can always call that. If you have a library prior loaded up, you can ask ftype for what kind of function is it, and in there it will say it's a generic function at the end of the day. Okay, and this is called method dispatch. Okay, so some other things like sum or cbind use C at the end thing, and so these are known as internal generics. Don't worry too much about that. Okay. Given a class, the job of an S3 generic is to call the correct S3 method, right? So that job summary, that function summary, the job of use method summary here is to say, oh, you are giving me a linear model output. Therefore, I need to call the function specific for the summary function specific for this linear model output. Oh, you are giving me a numeric vector. Therefore, I need to find the code or the function specific for outputting summary information for a numeric vector. Okay, that's what the generic function's job is to do. Okay, so that's all it says. And the way the generic functions are written is we'll have the generic function dot the class of the object. So if it's a linear model output coming in, you'll see there's going to be a function called summary.lm to indicate this is the summary function for linear models. Or if it's a numeric vector, I think that's just going to be default. So it's going to be like summary.default. But if you've got a different type of object, such as, I don't know, maybe there's a summary function for date types. You can do summary dot, and we can kind of see the different types of objects that have their own specific summary function. So we have a summary function for data frames, we have a summary function for dates, we have a summary function for linear models and general linear models and factors and all sorts of stuff, okay? So this is how we do it. There's a few functions that don't follow this rule. So for example, you guys are probably familiar with the function t-test for running t-tests, okay? In R, this would, if we followed the strict naming convention, this would be the T method for objects of class test, the way this is written. But this is an exception. T.test is running a Welch t-test type of thing. But other than that, or if we have print.dataframe, is this the print.data method for objects of frames, or is it the print method for data frames, okay? We know that it's the print method for data frames, but the way it's written, it could be a little bit confusing, right? So we have, so if we say, print f-type t.dataframe, this is a method, this is the transpose method for objects of data frame, whereas t-test is not the transpose method, it's the actual t-test. And so it knows how to do that. Okay. So all of those things that are, that belong to an object, those are called methods. So I could say, what are the methods associated with summary? Okay, and so these are all the different methods. So we have, a summary method for linear model objects and a summary method. Kind of the default is what we normally do for displaying vectors, but we have summary functions for other things, right? So we'll have, there's methods associated with mean, okay? And so we have mean.date, mean.default, mean.time difference, I guess, okay? If I do methods associated with print, there is a lot, okay? 205 methods for print, right? And we don't have to memorize all of these different ones. We just have to call print. And print will figure out which of these code is appropriate to use for the thing, right? There's a print method for summary models, summaries of linear model objects. Okay, so there's tons of these different things, right? So we can see, what are the methods? Okay, we can also find all the generics that are associated with a given class. So if we have a class of TS, which is time series objects, we can see all the methods that are associated with that. We can see methods for class equal to LM. For linear model things, we've got the summary, but we can also look up different things, right? The effects or the ANOVA on the summary model or things like that. Okay, and then when you call plot on a linear model, I think you guys may have seen this or may not have seen this, right? When you call plot on a linear model, it gives you like a series of 5 plots, one of them being kind of like the residuals and things like that. How does it know to do that? Well, we have a function that says this is how you're supposed to plot a linear model. Don't just plot, the scatter plot with the linear model line running through it, but plot out the residuals and things like that. Yeah.
So we're putting a quote at the side of LM. So how does R know that we're calling for like a function instead of the 2 letters L?
I'm sorry.
So normally we put the quote at the side of the characters. The R will treat this as a character.
Right.
But how will R know that this is actually we're calling for the function L?
Well, I'm not calling the function LM here. I'm saying what are the methods associated with the function that has the name LM? Yeah. Okay. Yeah. Or the class object class that has the name LM. Okay. So the methods we have, basically we got a generic function, and associated with each generic function are versions of that function that are specific for different object classes. Okay, so what if we want to create our own type of object class and create our own methods specific for that object class? Well, we can do that using the command structure. Okay, so we can say, I'm going to create an object foo, and we'll use it using structure. Basically, all I'm doing is I'm creating an empty list, but we're going to give it the important attribute that class is equal to foo. Okay? Or the other option is I could create the object itself. So foo is just an empty list, and then we update the class, and we just say the class of foo is foo. Okay? Class type foo. So now this automatically creates object of class foo. Okay, and that's it. All right, so objects of class foo is this. Okay, there's something called inherits. Okay, inherits means we're going to, there might be methods already defined for, let's say, like linear models. Okay, well, maybe we're going to make a special type of object that's very similar to linear models but is a little bit different, right? But we can benefit from all the functions that have already been defined for linear models. We can say, my new special type of linear model is going to inherit from the class linear model, and that assigns all of this stuff for us, okay? In this case, the object foo inherits from class foo, and that's true. But we can, if we needed to, we can say, class, special linear model, contains linear model, and then that will indicate to R that if you don't find something that's specific to the special linear model case, then just use the regular linear models. And if you don't find anything specific for that, then just use the generic function or the default function. Oh yeah, okay, so for example, the class of an object, S3 object, can be a vector, which describes behavior from the most specific to the least specific. For example, the GLM object is like a special case of the linear model, and so you'll have methods that are specific for GLM model, GLM objects, okay? And if R finds methods that are specific for GLM, it will call that. But then if it doesn't find methods specific for GLM, but finds it specific for just LM models, then it will go on to using the methods for the LM, right? So it just, and then if there's nothing for that, then it uses the default method. Okay, so this means the GLM, or the generalized linear models, inherit behavior from the linear models. Okay, class names are usually lowercase, and you should avoid using a dot inside the name, and this is indicates the hierarchy there. A lot of times you'll create a function for creating the objects of that class, just like to create objects of class factor, we often just say factor, and then we put in kind of the vector that we're using. And that tells R, take this vector and turn it into class factor, right? And that's called a constructor function, which basically says what you're going to output is of a certain class. So here is an example constructor function of just taking a vector x and putting it into the structure here. So it's going to be class factor. Okay. It says no check for correctness, okay? So S3, R doesn't make sure that you are running certain things. So in this case, I've created a linear model. This is my model. And if I ask, what's the class of model? It's going to say it's a linear model object. And then if I say print the model, then it calls its own print method, right? This is how it prints out the linear model. I could, if I wanted to, this is a bad idea, but I could say, you know what, this model that I created, it's not class linear model. We're going to turn it into class data frame. All right? R doesn't check. It just says, okay, I'll do my best. And when we do that and we say print out the model now, it prints out a data frame with 0 rows, or it says 0 length rows, right? It doesn't know how to do this. It doesn't know how to. It's trying to use the data frame method for printing this out, and it's struggling with it. Okay, the information hasn't been lost. It's just R is now kind of confused because it says, "Well, I thought you told me this is a data frame, and I don't see data frame information here. So when I try to print this out, it's going to look funny." Like this. All right. If you used other object-oriented languages, this feels really weird. And as far as R goes, though, just don't do stuff like that. Okay? You can say, I want to change the class of the model to data frame instead of linear model (LM), and you can break your code that way, and R will allow you to, but it's just, if you avoid doing silly things like that, you'll be fine. So let's talk about defining our own generic function, okay? So all we have to do to create a generic function is we just use that command use method. So here I'm creating a function f, and this is going to be a generic function because all I'm saying is use method f, all right? And so now this f is going to be a function where I can just call f on objects of different classes, and it will run code specific for each of those classes, right? So here, we're going to create f.a. This is code specific for objects of class A. And all this is for simplicity, the function will just return the character string class A. So basically, if you give the function f an object of class A, it will run this code f.a and return the code, or just return the text class A. So here, I'm creating an object of class A. It's an empty list, and we're saying class A. What's the class of A? It is A. And then when I run f, the function f, not f.a, but when I run the function f is a generic function, so it calls use method, and it says, what did you give me? Oh, you gave me an object of class A, therefore I will find the code f.a and run this, and it outputs that string class A. Does that process make sense? So we are calling just the generic function f. The generic function f says, figure out which method is appropriate, and when it does that, it says, oh, it's an object of class A, therefore I need to use this function f.a. Okay? We could create a new function, right? Or another method, and mean is already a generic function. When we looked at mean, it said to use method mean, right? So we could create a function called mean.a, and then now R will say, oh, I'm supposed to use this code whenever the mean function is called on objects of class A, right? So if we say mean.a is just going to return the character A, That's it. Okay, so all it does, so when we give it the object A, mean of A, we'll call the use method thing and says, figure out which method is appropriate. It goes through and it says, oh, look, I found a method that's appropriate. Let's run the code. That code just gives out the character A. Okay, you can, yeah. So here, I can create additional things, right? So f is a generic function of A, generic function f. We have a method specific for class A, and then we have f.default is the code that will run if it doesn't get anything that's already predefined. So anything else, if it's not class A, then it's going to run the default function. Okay. So so here, let me come over here. So here's function use method f. Okay. And then it figures this out, right? But if I create something object B here, okay? So if I say, what's the class of B? This is class B, and if I call f on B right now, it's going to complain. It's going to say, no applicable method for f when you give it a class of B, okay? That's because I haven't defined the default method here, all right? As soon as I define the default method, it's going to say, well, I have a function specific for object A, or class A, but here, now I have f.default, okay? f.default now will run when I call f on B here, okay? So now that I've defined a default thing, it's going to say, okay, I couldn't find the method for objects of class B. I only have a method for objects of class A, so I'm going to use the default method, and it works. Okay, so here, if I throw in the structure A, it will return class A. If I say the class is B and A, there's no B method for class B, so it uses the method for class A, because it's going to search for this first. If it doesn't find it, then it does this. And then lastly, if it searches for methods specific for class C, it doesn't find anything, and so it returns unknown class here. It uses the default there. Okay. So again, for this one, it searches for this, it doesn't find it, and so it searches for this, it finds it, and returns class A there. Okay, this is a slide, probably too much information there. You can call the function directly for something. So here, C is a object of class C, okay? And we could say, I want to run the method for class A on this object of class C. You could force it that way. You could say run f.a on class C, and it will run the method for that thing. Okay? It doesn't check, but this is again a bad idea. This is why the whole purpose of these generic functions is that you just call the function f on this, and it figures out which one it's supposed to run. But if you wanted to, you can say, I want to run this specific method on this object, and it will run that specific method. Yes?
Can you do that last slide? It doesn't change the class of C.
It does not change the class of C. It just runs the wrong function on that object type. Okay? All right, and that's it for S3 stuff. So we'll end here, and we'll see you guys on Wednesday.